Welcome back, ladies and gentlemen, to Soluna Computing's channel, modular, scalable data centers that convert wasted renewable energy into computing power for intensive batchable applications, everything from cloud computing to crypto. We're going to be diving into this as some of their projects continue to mature. Joining us, as always, John, the CEO, to kind of take us on the helm on 2024. Welcome back, sir.
Thank you, Kyle. Happy New Year. Welcome to be back.
Yeah, Happy New Year and a pleasure to get you back on. So I really want to get into this because, as you mentioned before we went live, a lot of talk about cryptocurrencies, Bitcoin. I know you guys have a play in this, but before we talk about the broader crypto sector, Dorothy, one of your major projects has outperformed traditional centers with an 18% lower carbon footprint. Looks like things are continuing to move in a good direction here with you guys. You want to break down Dorothy and what you're seeing there?
Yeah, absolutely. We just put out this announcement recently that shared a study we've been working on for the past year around looking at the load profile of Dorothy, the shape of the power in that region, and the carbon footprint of our facility relative to other data centers in the ERCOT market. And I think I'm really excited and proud to say that our facilities and our design, our approach to putting the facility behind the meter, focused on eating wasted or curtailed energy, has created a solution for renewables. But it's also proven that you can build data centers that are less carbon intensive for applications like Bitcoin and other applications, especially as it relates to AI. And I think the big news, to put it in context, is to show you some data. Let me see if I can bring that up for you here, Kyle, so you can see we build these facilities behind the meter and we source power. It allows us to source power from three places: from subtractive energy, which is energy that would otherwise go to the grid, but we are pulling it from the power plant. So that's green electrons powering our facility. The other is curtailed energy, and curtailed energy is that energy that would otherwise be wasted and today cannot be monetized by the power plant, either to congestion, power prices, other technical issues with the grid. We are consuming that energy and monetizing it for the power plant. And then the third option is grid energy. So when this wind farm, this is Dorothy's layout here, when we're sitting behind this 150 megawatt wind farm and suddenly the wind stops blowing, we still need power. And so the solution to that is to draw power from the grid. And we're able to do that because we're behind the same substation there. So the question is, now that this facility is here, it's running and operating, what's the carbon footprint of this facility and how does that compare to other data centers? And the answer to that question is this: typical data centers in the West Hub area of ERCOT consumes 162 megatons or produces rather, emits 162 megatons of carbon based on their energy usage, the fact that it's on 24/7, and their locations on the grid. These things tend to be closer to big metro areas, very large facilities, etc. And Soluna's facility, Project Dorothy, which is meant to be our flagship, our example of what we're going to scale as a platform company, consumes 18% less than that. And that is huge. That's 132 megatons compared to 162. And the driver for that, you can see from this slide, if you look at the consumption on an annualized basis, like total consumption, most of that is our location. So what we're saying is we place these facilities close to renewable energy plants. We place them way out in the rural areas where this green energy is rich. So that location gives us exposure to electrons that tend to be more green, because we're sourcing 70% of our power from the power plant. Our load is flexible. So the fact that we're not on 24/7 allows us to source power from different locations. We can make the load bigger or smaller using more green electrons when we're smaller. And of course, the fact that we use curtailed energy has a significant effect on reducing that. So the combination of those three things makes our facility more green than your typical data center. Now, here's another thing. When you look at the emissions on a output basis, on a rate, so this is like total emissions. This is like the rate, right? So our location has a bigger effect, and our use of curtailed energy has a bigger effect. Now, this is a similar study looking at the rate of emissions that was done by WattTime. WattTime is the company that appeared in that famous or perhaps infamous New York Times article that came out last year that, hey, these data centers are really bad for the grid and they're you're producing a lot of carbon. And there was a lot of backlash and lots of activity on Twitter. And we took the same analysis that they did. We use better data. We're working with a company called Resurety that has much more granular data around local marginal emissions. And what they analyze is that at our location, our emissions input relative to our peers in the same area is 40% less. So we're 40% greener than the average crypto miner in the ERCOT region. That's a very exciting result from this study for us, because that's what we've been saying. This is the vision we've been creating as a company. Can we build greener data centers that can be built in non-traditional locations, integrated with renewables to power all sorts of compute applications, and really align the future of computing with the future of climate change and the way we see green electrons?
Yeah, definitely appreciate these insights. And I see a lot of synergies too as the world evolves with power storage and batteries. And it's just neat how all of this kind of plays into it. But I also want to mention, as this becomes kind of the blueprint for the rest of your scale and growth, do you want to give a little update on the other projects like Katie that's starting to mature as well, and kind of what you're
Yeah,
seeing
absolutely.
bottom side of
Yeah,
the projects?
absolutely. Because I want to touch on this 18%. So we studied Dorothy. That's a 50 megawatt facility. We're going to make that facility bigger. We're also building more facilities around the state, and we're planning to build more facilities around the country. So we're building more compute power that has a lower carbon footprint. Katie, for example, has been moving faster than Dorothy did in through the ERCOT process, getting approvals, negotiating with the power partner to finalize the definitive agreements, and that's moving along fairly quickly here. And we're feeling comfortable about Katie becoming investment ready here fairly soon. And so let's say we stand up Katie, and it's equally as outperformant, if you will, as a data center relative to other players. You can start to think about multiplying this, right? So if we could get other data centers or data center players to replicate what we're doing, that 18%, if you applied it to the entire data center network, would essentially take a 330 megaton experience, right, where data centers represent about 1% of the total market, and reduce that by 80%. You're talking about 60 megatons that we would reduce. That's the equivalent of taking 13 million cars off the road every year. So from our perspective, the more we scale, the more we prove out this model, the more we prove that different types of compute can benefit from being integrated with renewables. It really then creates a blueprint for how we should look at building data centers in the future. And that's the company we'd like to become. So we're pretty excited as we get these projects off the ground. It's going to create a whole new company for us.
Yeah, I think you just gave a lot of clerical view. And just to follow up with perhaps some of like the investor Q&A front, as mentioned, when it comes to Bitcoin, as you kind of run some miners there, are you seeing any kind of extended profitability from the hash rates with the current Bitcoin price that is starting to come back with a vengeance here? I'm sure a lot of people are surprised by where Bitcoin's sitting at 2024, but what are your thoughts and what are you seeing on the ground floor?
Absolutely. So our business has transitioned from being primarily proprietary mining to mostly hosting. So I'd say it's probably more of like a 70-30 split at this point. So out of 75 megawatts that we have under management, 25 megawatts of them are proprietary mining. So about a third of our business. And so the way to look at what happens to our revenue and growth when Bitcoin has these positive actions like it's had in the last quarter, is the assets or the data centers that are either primarily prop mining or hosting with a profit share, which is our Sophie facility. You're seeing pretty significant direct correlation to increases in our revenue. I'm not going to mention percentages here, but you can feel comfortable that the growth in that price action has really benefited us a lot in the last quarter in terms of revenue growth, especially on Dorothy 1B and our Sophie project, where we have that profit share component. That's the way to sort of think about what's happening to our business. Folks have reached out and said, what does that mean in dollars and cents and so forth? And I'll think about putting something perhaps in our next business update that gives a quantification of that relative to each of those sites. But I think it's fair to say that we've definitely been buoyed by the growth in hash rate over the last few months.
Well, on that, I'll pass it off to the viewers. If you guys want updates as news and catalysts continue to come into play, consider subscribing for those future updates and catalysts. But on that note, we look forward to catching the next one as always.